Okay, anybody have any homework questions? Any problems you'd like to see me go through carefully or anything like that? Okay. I don't want to delete this. I'm sorry, what?
Number 7?
Number 7, okay. Let's see, let me pull it up. On which ones? The scientific notation?
No, on the one letters.
Oh, okay, I don't think we've gotten that far yet. Yeah, let me just show you quick, just, it takes a while for everyone to get used to how this is structured. So it makes very good sense that that was tricky because we haven't covered that material yet. Okay, so the assignment that I gave on Monday was just numbers 1 through 3. Okay. Any of those questions anybody would like to see? Okay. So we talked about what position is and sketching position versus time graphs. So now we need to talk about what velocity and acceleration are. So velocity. In everyday speech, people tend to think of velocity and speed as meaning the same thing. But in physics, they mean something related but a little different. So velocity we'll call it lowercase v, is plus or minus the speed. So, you know, a speed is always positive. A cop never pulls you over and says, do you know you are going negative 40 miles an hour or whatever. It's always positive, you know. Velocity can be positive or negative. And that positive or negative sign tells you the direction of the motion, the direction you're moving. So for example, this all can get a little confusing. But let's say that you have a car going this direction and it's moving 30 meters per second. That's about 70 miles an hour. And let's say that we have chosen our positive direction to be this way, okay? The speed of that car at that instant is 30 meters per second, okay? The velocity is plus or minus 30 meters per second, and then you have to think about which direction it's moving. In this case, you know, if the positive is going to the right, that means the negative is going to the left. So this car is moving in the negative direction, so the velocity is negative 30. Okay? And so if you know the sign of the velocity, you know the direction the car is moving. Velocity of 0 is 0 speed, so that means it's not moving at all. Okay, so a velocity that's positive, let me just write it as positive. Means the object is moving in the positive direction. A velocity of 0 means the object is at rest. And a negative velocity means the object is moving in the negative direction. On a position versus time graph, the velocity is the slope of the tangent line.
What's the difference between velocity and speed?
The speed is, you can think of the speed as the absolute value of the velocity. Yep. So the sign of the velocity tells you the direction it's moving. The speed doesn't tell you anything like that. You know, like if your speedometer on your car told you velocity, then when you were going to northern Minnesota, it would be, say, positive 60 miles an hour. And then when you were heading back home, it would say negative 60 miles an hour. Right, exactly. Okay, so just a reminder about the signs of slopes. This line has a positive slope. This line has 0 slope. And this line has a negative slope. Okay, so let's think of just sort of a made up position versus time graph and think about what we can tell about the motion from it. Okay, so let's think about 3 different points. The point A, B, and C. And let's think about what direction the object is moving in at these points. What direction is the object moving at A, B, and C? Okay, so for A, half of you have had the lab this week and you've done this kind of stuff. Half of you haven't yet. But here's how you find a tangent line. Draw 2 points nearby to the point you care about. And then just draw the line that goes through those 2 nearby points. So there's the tangent line at the point A. Okay? So for the point A, is the slope of that line positive, negative, or 0? Yep. So the slope is positive. That means the object is moving in the positive direction. Now the point B. So draw the 2 nearby points. Draw the line that goes through them. So that's the tangent line. Does that have a positive, 0, or negative slope? Negative. So the object is moving in the negative direction. And then the last one at this point C, draw the 2 nearby points, draw the line through them. Does that line have a positive, 0, or negative slope? 0. And so the slope is 0, and that means that the object is at rest at that instant. Okay. So now I'm going to write a problem down, give you a little time to think about it, see if you can think through this. So we're going to be talking about a motion along, so let's say this is the motion. And we're going to say positive is that way, negative is that way. Okay? So this is like the real world. This is where the thing is actually moving. And then over here in math world on the position versus time graph, let's say that we want to know, let's do an A and a B. Okay, so first, in the real world, draw an arrow in the direction of the object's motion at the point A. And then we're going to do the same thing with B. You can do that now if you want. I'm going to just write that down after we finish the first one. But okay, so what you have to do this problem is you have to interpret the sign from the position versus time graph. And then based on the sign that you got for the velocity on the position versus time graph, you have to decide whether it's moving to the left or the right in the real world. Okay? So take a minute and see if you can make that connection. Okay? Okay, so for the point A, first we have to figure out what the sign of the velocity is, and that's going to come from the position versus time graph. So I'm going to draw 2 points nearby to the instant that we care about. Draw the line through them, so that's the tangent line. Does that have a positive or negative slope? Negative. So we know that the velocity is negative because the slope is negative. And then in the real world, does negative go to the left or the right? It goes to the right. So based on this position versus time graph, at the point A, at the instant A, this object is moving that way, to the right. Okay? Okay, well, let me actually draw a third point, why not? So do the same things at B and C. Okay, so for part B, for point B, the 2 nearby points would be like this. Draw the line through them, and the tangent is that way. So is the velocity positive or negative? Right? So V is positive at B. And so in the real world, is the object moving to the left or the right? Left, correct. And then at the point C, the 2 nearby points are like that. So the tangent line is this. So is the velocity positive, negative, or 0 at C? 0. So the velocity is equal to 0. And so if the velocity is 0, the object isn't moving at all. So wherever the object is, it's just sitting in place. It's not moving either way. Okay? With me on that?
So would you draw anything on the real world thing?
That's a good question. I probably, if I put that on a problem for you, I would try to make it more clear how to demonstrate it. But as long as you understand that 0 just means it's not moving. Okay, So that's really all you have to know about the velocity. So now let's talk about the acceleration. In everyday speech, acceleration means speeding up and deceleration means slowing down, okay? Yeah, let's say that, in everyday speech. Acceleration means speeding up, and deceleration means slowing down. In physics, there's no such, we don't talk about deceleration, we only talk about acceleration. And acceleration just means any change in velocity. And so really what it is how quickly the velocity is changing. In one-dimensional motion, like we're doing right now, it can mean speeding up or slowing down. In two-dimensional motion, which we haven't started talking about yet, it can mean speeding up slowing down, or turning. Because turning is also velocity changing, and we'll talk more about that later. But so once we get to 2D, you can have cases where the object is staying at the exact same speed, going around a turn or whatever, and there's going to be acceleration. Okay? In 1D, you don't have to think about that yet. It's only speeding up or slowing down, but it's either one of them. Okay. The sign of the acceleration tells you something about whether it's speeding up or slowing down, but it probably isn't the way you would imagine it. So here is the way it works. A positive acceleration means that the velocity is moving towards positive. Zero acceleration means the velocity is constant. And negative acceleration means the velocity is moving towards negative. The result of this, okay, moving toward positive and toward negative. The result is that if the velocity and acceleration have the same sign. The object is speeding up, whether it's positive or negative. If the velocity and the acceleration have opposite signs, the object is slowing down. And if the velocity is equal to 0, well, you can't get any slower than 0. So you have to be speeding up if there's acceleration. So then the object is speeding up. In the direction of the acceleration. So probably, I mean, it wouldn't really be a fair question, but if I asked everybody to guess, okay, so I tell you that acceleration can be positive, 0, or negative. What does it mean if the object's speeding up? You probably would guess that a positive acceleration is speeding up and a negative acceleration is slowing down. But that's not how it works. So notice this. In order to know whether something's speeding up or slowing down, you have to know the sign of the velocity and the acceleration. And if, say, they're both negative, then the object is speeding up in the negative direction. If they're both positive, it's speeding up in the positive direction. If one is positive and one is negative, it means the object is slowing down. Okay? Any questions right now about acceleration? Okay, so what does acceleration look like on a position versus time graph? So on a position versus time graph, non-zero acceleration always means the graph has curvature. If the curvature is part of a concave up shape like that, that means that the acceleration is positive. You know, like it has a positive attitude. So you can remember it that way, you know. If it's a straight line, it could be any of these. There's no acceleration. It's 0. And if it's part of a curve like that, that's a negative acceleration, like a negative attitude. Okay, so let's think about part of a position versus time graph. And let's think about 2 points, A and B. What are the signs of the acceleration at these 2 points, at A and B. Well, at A, does that look like part of a concave up curve like this, like a smile, or part of a concave down curve? Down. And so at the point A, acceleration is negative. At B, does that look like part of a concave up or concave down curve? Up. So that's a positive acceleration. Okay. So let's say that's a position versus time graph. And we'll call that point A and that point B. And let's say that this represents a horizontal motion where positive is this way and negative is this way. Okay, I'm going to draw this for both of the two cases. Or for both of those two instants. For each point, find the sign of the velocity, the sign of the acceleration, and then figure out if it's speeding up or slowing down. Okay, so take a couple minutes and see if you can think through this. You're going to get the sign of the velocity from the slope of the tangent. You're going to get the sign of the acceleration from the concavity. And then you're going to use these rules to determine whether it's speeding up or slowing down. Okay? So see if you can think through that. I'll give you a few minutes.